Hey guys, welcome to step 3, calculating excess reactants, okay? So now in some of your problems, you could potentially calculate this before you calculate the mass of the product. You could do it kind of both ways, but it's step 3 in our process today, okay? So if you ever get stuck on how to calculate the mass in excess, come back to this video, all right? So I kept everything that we've calculated from our first 2 videos. We know our chemical equation, we know which one our limiting reactant is, and we know our how many moles of each element we've been given, okay? So now we know that O2 is in excess. And so now we want to figure out how much O2 is used and how much is left over, all right? So let's go back to our mole ratio of oxygen to phosphorus. It's going to be, again, with our coefficients 5:1, okay? So we know that we need 0.202 moles of phosphorus. Now we're going to multiply that by our ratio of 5 moles of O2 for every 1 mole of phosphorus, and calculate that if we have 0.202 moles of phosphorus, we are going to end up using that times 5, which is 1.01 moles of O2 that is needed, okay? All right, so we only need 1.01 moles of oxygen in order to complete this reaction, okay? So now we can figure out the mass of oxygen that's needed by converting this, okay? So we have 1.01 moles of O2. Now we're going to do our moles to mass conversion. We know that the molar mass of oxygen oxygen gas, which is O2, is going to be 32. So we have 32 grams for every 1 mole, and we end up with 32.3 grams of O2 that is needed. So now how do we calculate how much extra? Well, we were only given 50 grams to start. So 50 minus 32.3 grams means that we have 17.7 grams of O2 in excess. All right, so that is how you are going to calculate how much of a reactant you have in excess. So keep an eye out for me for the posts on this, but these are your videos if you really want to break it down step by step, okay? Good luck, you guys.